In this video, we're going to walk through an introduction to Outer Bounds using the machine learning end-to-end tutorial. We're going to see the user experience both for an end user. You can see here this account is a member, and we're going to flip back and forth between this account and an admin account. To get started, on the member account, I'm going to go over to my Learn tab. This part you can do if you're an admin or a user. There's certain things that are admin-only actions that we'll go through throughout the video. So you can see there's some getting started content here. There's documentation. The thing that we want to go to is the XGBoost example. We'll go ahead and click Start Journey, but the first thing that we notice is that we need a workstation to run the journey. If you want a workstation as an end user, this is an admin-only action to create the user. So we can go back to our admin account. In the real world, you'd have to ask in the Slack channel or maybe some internal chat to have your admin invite you. So we will go to Workstations. Let's see if we already have a workstation for this user. The user is going to be the eMatea email that we saw on the other site. Looks like we have a bunch of workstations, but not one for that user. Let's go ahead and create one. Here we go. We'll say can only go into a certain compute pool. Some of this stuff is a bit beyond the scope of the beginning of this. And we'll name it XGB Dev. Okay. Looks good. Let's go ahead and create that workstation. All right, at this point on the admin profile, I can see that the workstation has been created. It's running on an M5.2x large instance. In this case, we're running our Outer Bounds compute pools on AWS. And the workstation is now in the running state. What that means for the user profile, if we click back, is that now I should be able to start the journey. But before we do that, we can just quickly click on workstations, and we can see that under my workstations, yes, indeed, I do have this running. So if I go back to the Learn tab, there we go. We'll be able to start that up. So you can get started by reading through this document if you'd like. I'm going to go ahead and skip that to keep the video concise. The next step, we're actually going to have to do one more action that requires an admin action. So on Outer Bounds, the compute layer, regardless of the cloud that you're on, is going to be defined in what's called a compute pool. So if I go ahead and click on pools here, you'll see that we have a bunch of different pools. We have Demo API Server, Relay Tests, GPU Inference 24GB. These are all different groups of, you can think of them like a Kubernetes node group, that are able to schedule different jobs. So users are not allowed to create the compute pools. That's an admin-only action. What the instructions say here is that we want to create an XGBoost tutorial compute pool. And one thing to note is that you kind of need to know something about the types of workloads that you're going to be running in a compute pool. There's other parameters that you need to know that you'll get familiar with in your Outer Bounds onboarding. The main one that we need, the main constraint that we need to actually run this content in our case, is at least 14 CPUs on the computers that we're going to be running the job on. So I'm going to go ahead and copy paste this name, which we'll call the pool XGBoost tutorial, and then we'll see how we invoke this as a user later down in these other steps. So let's go back to the admin page one more time. We'll head over to the compute section under the platform header, and we'll go over to pools. Click Add Pool. You can see where there's many different places you could acquire compute on Outer Bounds. We're going to stick with AWS. Name it the XGBoost tutorial. We'll keep this region. For instance, remember we need something with 14 CPUs, so I think C5.4x large makes sense in this case. There's all sorts of different options, of course, for different cloud providers to consider. And we'll leave the default settings here. On advanced routing, one thing that you'll need to take note of is that we want to run Metaflow tasks to complete this tutorial, so you'll want to click the Metaflow tasks button. Earlier you saw me create a workstation, and I kind of assigned it to a specific pool dedicated to workstations. That's all that this routing means in this case. Go ahead and click Add. Similar to the workstations, this will take a while to spin up. So if I do a refresh, we'll see we have the XGBoost tutorial, the pool is being created, and once that's ready to rock and roll, now we'll go back to the user tab and we'll start running jobs and invoking this compute pool. Back on the admin view, we can see that our XGBoost tutorial compute pool is up and healthy. There's a lot of information to go with compute pools. That's beyond the scope of this tutorial. But of course, as you get familiarized with Outer Bounds, you'll learn all sorts of things about how to use the compute pools. All right, so now that's the last admin action we need. So we should be ready to roll to continue our tutorial from the user's point of view. This is VS Code in the browser within Outer Bounds. And before we dive in, let's explore ways to access Outer Bounds workstations more broadly. You can click the Workstations tab in Outer Bounds UI, and from there you'll be able to open the web UI to your workstation. You can also, from the same page, get instructions on how to open in a local IDE, including VS Code, Cursor, or Windsurf. And of course, you can run Metaflow tasks from anywhere. Okay, so we see we have kind of just the base thing. We don't actually have the content that we want to run for the XGBoost tutorial. So let's go ahead and pull that with this Outer Bounds tutorial pull command. And we'll go ahead and copy paste. We can see now that we have a bunch of different content. The one that we want to run is this ML end-to-end. But you don't need to do much beyond just click on to the next step. And then we'll go ahead and open the first notebook. All right, so the thing that we want to build, this first workflow that we want to build, is we're going to train different XGBoost models. So this is a Metaflow DAG architecture where you can think of each of these circles corresponds to a Metaflow step. The whole drawing corresponds to a Metaflow flow spec. What we're going to be doing is pulling in data from a Postgres database that's external to your Outer Bounds deployment. We're going to be then running each of these steps. These are the heavy compute tasks, these cross-validation steps, where we're running k-fold cross-validation, each time training an XGBoost model for each fold, and then we're dumping that model as an artifact into object storage. Go ahead and start the notebook. Have to do some quick installations. All right, and then we'll select a Python environment. You can just choose this base Python 3.12.7. If you know your way around Python dependency management, you can, of course, create your own environment. Okay, the notebook is pretty involved. One of the main things you're going to have to do is run this pip install command to get started. This isn't really the main part that I want to go through. This is more about understanding the data science problem that we're actually solving here, which is not really the main point of this video. The idea here is not necessarily to go through everything in detail in this video. This does familiarize you with the core source code that we're using, some of the dependencies that we're invoking here in our workflows, also to show kind of how to share a common module between notebook code, Metaflow code. You can see this is the kind of data set we're working with. We have a time series for different regions. And this time series corresponds to energy consumption being sent across the energy grid in different regions of the Northeast United States. And we want to model these time series using XGBoost models. Okay, so keep going. We can see this is kind of the full data set. So each different color represents one of the regions. Of course, we have the time on the x-axis, and then we have the megawatt hour consumption on the y-axis. You can see obvious cyclicity and different kinds of patterns in the data. This notebook is in large part about understanding kind of what are these patterns. Here we see some moving averages kind of broken out by year and by region. You can see the actual task that we're trying to do is we're trying to train on the light green data here. And the test data is going to be forecasting this. The dark green is ground truth, and the purple is the prediction of the model. And that's the thing that we're trying to train. There's all sorts of different models that you might want to pick to do that sort of forecasting problem. In this case, we're going to featureize the green data, and then we're going to predict the purple data is the idea. So this is the task of the XGBoost model in our case. Of course, you can pick whatever model you want. You can do whatever Python code you want with Metaflow and Outer Bounds. In this case, we're choosing XGBoost. Then later, we'll see kind of how some of these different visualizations and things that we're using in the notebook can also be invoked in Metaflow and kind of used as monitoring when you run Metaflow pipelines automatically in the cloud without this interactive interface like a notebook. All right, so let's move on and start running the workflows. When I click This step here, you can see we have a command that we're going to run. So this smoke parameter, this basically just means we're only going to run for one of those regions that we saw. And then the other interesting thing to note here is that we're going to target the compute pool that we created. So that thing that we did on the admin interface that your admin will have to set up for you if you only have a member user profile on Outer Bounds, that is what we're going to run this compute task on, is this XGBoost tutorial compute pool. Now, the actual contents of this flow, again, not going to go super deep into the details of what the code actually is. That's kind of left to you and your own adventures as you interact with this system. Let me go ahead and open up the terminal. We can just briefly scroll through. So we're using Metaflow. No fancy automations or anything. These are just the base APIs of Metaflow. So this should run with open source Metaflow or an Outer Bounds distribution. Standard flow spec object using Metaflow parameters. And then the rest of it is just kind of the main code. One thing to pay attention to is earlier we talked about needing to have instances with more than 14 CPUs available, greater than or equal to 14 CPUs available. The reason for that is because this task, we're saying as a data scientist when we use Metaflow, we're saying that this requires 14 CPUs and 4 gigabytes of RAM in this case. Here I've noted that an M5.4X large would be one instance. I think we chose C4X large, if I remember from earlier. Doesn't really matter which you choose, I guess, in this case. The point is that this is sort of a problem that you're going to be having to think through each time you have a new workload and you want to assign it to a new compute pool in Outer Bounds. You have to kind of think about what is going to run in this pool, and then what are the resource requirements that I might want to be tuning as a data scientist as I build and optimize these workflows. Earlier, I mentioned some of the visualizations. The card feature in Metaflow, we'll see the outputs that this generates in this runs tab in a little bit. But this is kind of where we make contact with the visualizations we saw in the notebook earlier in Metaflow. And let's go ahead and run our commands. I'm going to go ahead and lift up the terminal here. We see after we start the command, Metaflow does its normal linting process. A thing that's different on Outer Bounds that we're doing is we're using the Fast Bakery environment builder. This is an Outer Bounds only feature. With open source Metaflow, you can use PyPy UV. You can see here we built a pretty complicated environment with quite a bit of heavy dependencies. And this whole environment built in less than 20 seconds. It built a Docker image. It's cached in the same cloud account where the compute pool is living, meaning that we'll be able to pull this image very, very fast as we start to run these different tasks on Kubernetes. So as soon as this task spins up, then all of these dependencies will be ready to rock and roll in that Metaflow task runtime for the start step, so on and so forth for the remaining steps. So we'll go ahead and let the Kubernetes cluster warm up a little bit. That backs the compute pool, and then we'll continue on with the tutorial after this flow completes. All right, jumping in here, we can see the start steps completed, spun up after about 2 minutes. The second step, this train model step then, since the compute pool already had an instance warm and ready to be scheduled from the start step just completing, the train model step immediately got scheduled there. You can see it already set up and downloaded the entire Metaflow code package, everything that it needs to actually start running the job. If you remember, the train model step is where a lot of the interesting stuff is happening in this specific Metaflow workflow. So let's go ahead and open up this runs link, which we'll go ahead and open it up in a different tab. So what we're seeing here is now on the left-hand side, we have the steps laid out. We can view the DAG all together. And that connects then to what we see on the left-hand side here. If we click into the train model, we have all sorts of info, such as the logs, kind of normal Outer Bounds Metaflow execution information here. And the interesting bit that's unique to this tutorial is going to be these cards. So this is the stuff that we saw in the notebook. And then we were talking a bit earlier about how that actually makes contact with your Metaflow code and how to take some of that stuff from the core modules that we built that are independent of Metaflow and how we can link those visualizations that we saw from the notebook into producing these visualizations inside of the Outer Bounds UI. So here we see some of our error analysis plots. We see the interactive feature importance dashboards that we built. And remember, these are all just kind of generated from Python code. We have a progress tracker that's updating in real time. So when we're training much bigger versions of the data set, or we're training across all the regions, and we have many, many parallel versions of this train model step happening simultaneously, we can track each cross-validation fold and get that granular information we need to make sure our jobs are running healthy. Okay, so this completed. Everything ran pretty fast. Took about, I guess, barring the roughly 90 seconds of time to spend warming up this C5 compute instance, the flow executed in about a minute. Okay, so let's move on to the next step then. We're going to go back to a notebook. So this is going to kind of see how you can move back and forth. It's not necessarily just that notebooks are for iterative development and then Metaflow is for production. It's much more of a back and forth in most real workflows. So what we're showing here is you could imagine that this notebook is any kind of analysis environment that wants to look at the artifacts or maybe pull down one of those models that we just trained in one of the trained model steps. Really anything you wanted to do, you can use the Metaflow client API in Python to access all of those artifacts or metadata about the flow that we just ran. Here, what we want to do is we want to basically do what we just did, where we set up this first training flow with a notebook and showed kind of those APIs in notebook land and then in a Metaflow flow. Now we want to do the same thing with a batch inference pipeline. So this notebook is representing the batch inference pipeline. And then in the next step, we'll build out this flow and run it, which is going to dump our predictions into the object store, or it could be somewhere else, DynamoDB, wherever your production applications that read these predictions need them to be. All right, so we'll connect to the same kernel, run our imports. There's a lot of stuff in this custom module that can show how to bring your business logic. Okay, so we're just going to take a look at these regions. We only trained one region. Some of these might not really matter here. Using the Metaflow client API, we're going to fetch the latest execution of our flow. And then we're going to find the information that we need, including pretty much everything that we versioned along with this run. Including, where to find the actual model itself, what hyperparameters that we use to train it, so on and so forth. Let's actually instantiate the model using the XGBoost API. We'll fetch some data, making our Postgres connection. Okay, so we know this is the most recent date time in the database. Remember, in that time series problem now, all we know is that we need to predict that darker green band into the future, where from the model's point of view, basically like the runtime of this notebook's point of view, we don't actually know what the purple stuff we want to predict is the data science problem we've set up. Obviously, we have the labeled training data that we're constructing by chopping up the data, the time series data in this way. That's what we're trying to predict. So this is how we construct the next set of times that we need to make a forecast for. And then we'll go ahead and actually just call the prediction API for the model. So here you can see we're just using the normal XGBoost model.predict API, collecting the predictions into a data frame. And here we can see this is the next forecast. So in this case, we are predicting for 1 day's worth of time, 24 hours, one prediction on the hour. And these values are essentially what the model is saying should be. This is the prediction for the dark purple. So actually, let's go back and actually just find that quickly. If we go from our run here, and we go back to the cards that we are looking at, what I'm talking about is on the CV plot, that data frame that we saw without the labeled values, the times was this dark green thing. All we really have is access to the x-axis. Dark green again is ground truth, and then that data frame that we just computed with the model.predict function is this purple. Okay. Let's keep moving. Same thing that we saw as the difference between steps 4 and 5. we're going to do with steps 6 and 7, again, showing this using our custom module in a consistent way across notebooks and Metaflow workflows. We'll talk about eventing later. This is an important thing where, especially with inference, you can imagine whenever we have new data, we want to run the forecast. This is what we're setting up here. We'll get to later down the line. Similarly, we have standard Metaflow flow, part of the same PGM project. The start step is accessing the forecast that we need to predict. So it's giving us this empty data frame. And then we are going to pull down the model that we have connected from our previous train step. And we're going to make our predictions, save them as our artifact here, which is the Y predictions out of sample. And then that becomes our predictions data frame, just as we saw in the notebook. And this is saved, importantly, as a Metaflow artifact. So this is what I was talking about earlier, where it kind of the predictions from that previous chart that we saw. Let me actually just click it quickly. The predictions that we saw from here, this blue output, these are being stored as a Metaflow artifact. This could be, of course, you could push them to object storage, you could write them to Snowflake or Databricks or wherever you store the predictions that you make and then consume them from your production application. Okay, so let's run this. Similarly, again, remember we're targeting the same compute pool, so you can see how we're doing that with Kubernetes here. Go ahead and open up the terminal, and we'll run it. This time the image bakes very, very fast. Okay, we've hit an interesting error here. So one thing that we've got set up as the part of the parameters of this workflow is we're going to consume the model from the upstream training flow that we ran. So what we can see here is we're setting the project, and we're using this to assume the Metaflow namespace that we want to fetch our training run from. With Metaflow, there's different namespaces. There's one for prod, there's one for a test or staging environment, and then each different user has their own namespace where we run flows in. This helps you not clobber other people's work. It helps you maintain stability and version control around these workflows in a similar way to how Git versions your code. So the upshot is basically that we're trying to pull from this PGM Energy Forecast project namespace, which, if you remember, we actually weren't using that earlier. So what I'm going to do is I'm going to run the same command and then this example of how to use Metaflow parameters, where all I need is to just add this Metaflow namespace, arg is the parameter, and then our project was actually PGM, that visible in the workflow that we specified here. And that's also what we're specifying here for the inference workflow. So what this is showing is essentially, say you wanted to run this inference workflow in a user namespace, but you wanted to pull the upstream model from production. When you did that, from the production namespace. This is the kind of thing that you can do very naturally with Metaflow. That's what this design pattern is intended to show you. So this was kind of built in intentionally to help to sleuth through this problem. So I guess I'm giving away the bit a little bit here. That's the idea. We can see now that it's successfully ran. It's already ran the prediction step. So we'll have our predictions cached. You'll notice that we have a join step. Again, we have, similar to the training step, in this case, we're just doing the smoke test, so we're only doing it for one region. We only had one parallel prediction step. The join step is there because we can also parallelize over that batch inference computation. Okay, we'll skip the UI part. It's not too distinct from what we saw earlier. Less interesting than some of the training monitoring that we saw. Okay, so this next step, now we're going to get into a couple new Metaflow features and how they work on outer bounds. Specifically, we're going to be deploying this workflow to the production orchestrator with the Argo Workflows create command. And we're going to be invoking a pattern where we're going to watch that database that I mentioned, that external Postgres database. We didn't really talk about how that got set up or where that lives, but just kind of consider, the data engineering team set that Postgres database up for you. In this case, credentials are inside this repository. And so we have access to that database. And what we want to do is we want to check to see if the tables that we are consuming this data from when we train our model and when we run inference, we want to check to see if there's new data. And if there's new data, then we want to trigger that batch inference pipeline that we saw earlier. Okay, so the flow is not super interesting. Again, it does everything that I just said, and that's it. The key line here is we're making a check. If the data set's updated, which we measure that by this conditional statement, of course, in a real workflow, you might have like very, very much more complicated logic there. The main API that we're doing here is that we are dispatching this event, which then when we deploy our batch inference workflow to the production orchestrator, we'll trigger it to run automatically without any manual run. Okay, so let's open up our terminal and we'll go ahead and I'll just type this one out. It's a little bit shorter. Environment, fast bakery. And then instead of run, we're going to do Argo workflows. Great. Again, we're building with Fast Bakery. So even though we're running it on the production orchestrator, we're not immediately triggering this workflow. We're just deploying it. So it's waiting to run in the future. You can see we build the same environment, just like when we ran the flows. And this is already deployed. Okay, great. So the key line here is you can see this workflow triggers automatically when a cron runs. So that schedule is coming from the Metaflow schedule decorator. And you can see here we've specified it to run every 5 minutes. So you can see that on the Workflows tab. Once you deploy the workflow to Argo Workflows, you'll see it appear on the Workflows tab, which is right here. And we can see again that it runs every 5 minutes. If you want, we can also manually trigger it. Let's just go ahead and do that. Okay, so the point is that this thing will keep running and it's going to keep watching for changes in that upstream database, which we've programmed to update every 10 or 20 minutes or something. Again, that's just a simulation in that database. Imagine that part is the important data that you actually are training your models on. And maybe the data engineering team has already set that up. That's already an established thing. Okay, so I'm just going to let this thing start running. Step 9 actually explains why I kind of jumped the gun on step 9. Here we can see that the sensor that I just triggered manually already ran. Meaning we should see now that there's an event. This other tab here on Outer Bounds, the Events tab, we can go ahead and click there. And we can indeed see that within the last minute or two, when that flow was triggered, we did in fact produce this event on the Argo event bus, meaning that if we had deployed that inference workflow already, it would have automatically been triggered upon that event being put in the bus. We didn't deploy the workflow, so let's go ahead and continue to step 10 and 11, where that's what we're going to do. Scroll up to the top here. You can see now we are working on the flow. In the instructions, we say to uncomment the schedule decorator. So this thing now we're saying, let's deploy this base training workflow. We can run it every 10 minutes or so. Actually, I don't want to run, let's say I don't want to run it. I only want to do training manually. Would be a totally valid decision. You go ahead and then deploy this to Argo workflows. And then it could just wait. It could just be there, not on a cron schedule. Maybe we have some other kind of upstream event that we want to apply here with a trigger. The world is your oyster with the schedule and trigger decorator when building systems on Outer Bounds. We'll go ahead then and continue now to running our inference workflow, where this one, the trigger is much more important. So now we have that same event that we saw pop up in the event bus here, and that new PGM data event is on this basically the same flow as before. Not too much else has changed. So let's just go ahead and deploy that, and then we'll see what it looks like when the workflow gets triggered. Okay, great. So let's go back to the workflows page, just verify, sanity check. Yes, we have our XGBoost training, we have our XGBoost batch inference. If you saw here, we also can see that the trigger is going to be on that new PGM data event. If this one happened, again, now that we've deployed it, I'm going to see the actual thing run. Just to save us a little bit of time, what I'm going to do is go to our sensor workflow, the one that we saw earlier, and I'm going to manually dispatch the event. So I'm going to kind of assume that that conditional that we saw happened. So our code for that, let's go ahead and import. Just open up Python interpreter. We'll go ahead and open up the Argo event. And then the name of the event that we're going to want is the event that we published, new PJM data, .publish. So that's what happens when we hit the conditional statement that we talked about earlier. If we go over to the events tab now, give it a refresh, you see that event that we just triggered manually. And if we go to our workflows page, now we can see that there is indeed a workflow that ran in response to that event being pushed. Okay, so looks like it's already running. And we can see the same issue happened, so this is a bit buggy. Go back here, and we can actually just deploy it with, let's change the parameter. And this is a good instance of how easy it is to debug with Metaflow, where I can now just rerun the same Argo Workflows create command after making that quick change. Let's go ahead and do another manual dispatch of the event. Okay, so now we have this one, EF. Go ahead and verify on the events tab. All right, there we go. And if we go back to our workflows page, we'll have another workflow running. So this error is just saying that when you deploy this to production, we're not using that smoke test flag. We need to deploy the run with the all regions tag, or we need to kind of use the smoke test on this production version of the inference pipeline. You may or may not want to do in CI environments, but we kind of just deployed right to the production environment here. So you probably don't want to have the smoke test version of that as the default in production. But this thing would have run basically the same way as that flow ran earlier. You could even pin it to the exact same compute pools if you wanted. That's essentially the upshot. So the idea is that when this runs and we have kind of all the projects in the right namespace, then we'll be good to go. So the way to do that is if we go to our training workflow, you can see that the default is false, so we can trigger this. Maybe let's use a smaller amount just so it goes a little bit faster. And this flag is what we were talking about. So by default, it's false. Let's leave it false, and then we'll get rid of that error that we just saw. This part about the smoke test, by the way, it's important to note that this is about specifically how we chose to design these workflows in this specific project. There's nothing about that inside of Metaflow or Outer Bounds. This is more just a design choice and how we built this specific application. Baseline XGBoost training and the corresponding inference workflow. All right, so you can see our training run. And the thing that we wanted to verify earlier is that we had the tag. And we do have the all regions tag here. So what this is meaning is that we're going to have many different parallel workers going here. So if we see this region, kind of have our cards appearing, a lot of activity happening. Let's actually go click on one of these that's in progress. What we see why it's scheduling sequentially right now is basically a property of the autoscaler of our cluster. So as more instances spin up in the cluster, the parallelization will just kind of happen naturally. This is more just a function of how fast can our cloud provider that's backing the compute pool spin up the instances. So we see here slightly different data. We'll obviously aggregate across the different things. But this one is for the COMED region. This one's for the AEP region. And once this finishes, then we'll be able to find our workflow from before. Okay, so now we see what I'm talking about happening, where a bunch of different steps are coming in. The autoscaler spun up a bunch of instances at once, it looks like, and now these are running all independently. They're running independent EC2 instances since we're on AWS. Let's go ahead and check out the progress. You can see this progress bar updating live. Great. So we're finishing these pretty quickly. Should be done shortly. And hopefully we get lucky with one of these events being timed well. Let's look at our deployed workflow. We can go ahead and look at our, where's our sensor flow? There we go. So we'll be triggering this automatically in a couple seconds here because it's on that 5-minute cron schedule. There we go. So this thing should kick off another flow very soon. And now our sensor flow is kicked off. We've also triggered our inference workflow. So that means that we found some new data. Let's go ahead and check the event. Yeah, so we can see this event, which was published from our flow. You can see the payload here as well. You can actually add data here. This is an important thing to realize. So you can string together different things that you want to pass from one flow to another, or things that you want to pass from outside a flow from any environment you like. You can dispatch the event. Let's see if we're making any progress on our training run here. Okay, good. So we're on our end step. So once this closes out, then we should be able to run that inference workflow end to end. Actually, this one, once it gets scheduled, should be able to run here. This thing is waiting to get scheduled on the compute pool. Let's go ahead and see one other piece. So if you want, you can go ahead and click over into Argo Workflows where you can monitor. All right, so now that we're in the start runtime, we can actually pull the task. We can see now we've kind of fixed our problem. We both have the correct project and where it's lined up with our training namespace. And we also have that tag that we needed on the specific training workflow that we were looking at. So again, our DAG structure here. So now we'll be making different kinds of predictions. So once these become tasks, once those pods are scheduled, then we'll have parallel prediction steps happening. You can see 2 of them already spun up. So this is an artifact of the compute pool being already warm somewhat. We just ran the training workflow, and now all of these are, so basically all of the compute that was needed here was already warmed up inside of the compute pool. That's pretty much the upshot that I wanted to go through in this video. If you are curious, there's also more advanced modeling approaches. If I go into one of these steps that shows the code, let's go there. If you just want to play around with this on your workstation, kind of independent of this whole like learn tab and journeys thing. So if I go into this is how the content is mapped onto the right-hand side here. You don't really need to know anything about that. That's just kind of a specific thing about this feature of outer bounds. But what you can see is that inside the custom module, there's all sorts of other stuff as well that we didn't really get into. So there's another piece that does much more heavy computation, is why we wanted those 14 CPU boxes, but we didn't get into these sections 4 and 5. So we've completed through 0 through 3. The idea here is now to show what would be a next step in this workflow. So say you like the kind of system that you've built and you want to start iterating on the model. Now we can start to build different candidate models where we use different strategies for feature encoding. Maybe we tweak some of the XGBoost parameters in a specific way. Maybe we select a completely different model family, these kinds of things. And then we can deploy in the same project, we can deploy in the side-by-side project, run them side-by-side on production data, so on and so forth. This is the way with Metaflow. But again, going into the details there is beyond the scope of this video. So I think we'll close it out there. Thanks for your attention, and best of luck with Metaflow.